Welcome back, guys. What we're going to be looking at today is we're looking at a vector question, right? So this question came 2018, all right, CXC. So let's go. So the question reads, the diagram below, not drawn to scale, shows a quadrilateral ABCD. So we're looking at the quadrilateral. We're looking at the quadrilateral A, B, C, D. All right, so we're seeing that. All right, so quadrilateral A, B, C, D, where we got stuff like AB is M, DC is 3M, and AD is N. So we got all the relevant information right here. However, though, it is already labeled for us. All right, so it's already labeled, so we could see where they already put on the necessary labels that we're going to need. So complete the statement below on the geometric properties of the following vectors. All right, so they're asking us now, AB and DC are what? AB, so we're talking about AB, which is this vector here, and DC is this vector here. If you want to know what the vectors are and how they're related, you could look at what they are, what they represent. AB is represented by M. DC is represented by 3M. As long as we are able to factor out a scalar quantity, then we're able to show that vectors are parallel, because when vectors are parallel, one vector is a factor or a multiple of the other vector. For example, if I multiply 3 times vector AB, I will get vector DC. You could see where vector AB is M, and if I multiply M times 3, I'll get 3M. And that's the point we're making. So the point we're making is that when vectors are parallel, you are able to factor out something from one vector and ends up with the other vector. So in that case, we're seeing where AB is parallel to DC because I am able to factor out a 3 and get AB, or I could multiply AB by 3 and get DC. The fact that we're able to do that, it means that they are parallel. So AB and DC are parallel vectors. Right? Now, normally when vectors are parallel, for example, we're looking at this where 3AB gives us DC, or we could represent it as 1/3 DC gives us AB. Same information here. So we can represent the ideas either way. So in context now, the magnitude of vector AB is dash times the magnitude of vector DC. It's actually 1/3 times. In other words, this is DC, right? And if I can multiply DC by 1/3, I'll definitely getting M, and M is the vector AB. So then it's 1/3. The good thing about vectors, the moment you find the factor that shows you that they are parallel, then it is that same factor that affects how big one vector is in relation to the other. So definitely 3 times AB size the length of AB, 3 times that length will give us DC, or 1/3 the length of DC will give us AB. So if they say the magnitude of AB is dash times CD's magnitude, it is actually 1/3 of CD's magnitude, just like that. Express BC in terms of M and N. Now let's go. We have to look where BC is. So in order to do that, we want to express BC in terms of M and N. All right. So in order to do that, let's look. This is B and this is C. So we want to walk along this. But in order to move from B to C, we're going to have to travel from, watch this, BC. We would have to travel from B to A. That is from here to here. Plus from A to D. Then we move to here. And then move from D to C. Then from there. And then we would have accomplished that journey. So we're saying that, listen, all we have to do is to put together the ideas for these vectors. And remember, the directions are very important. So I'm going to go BA, but we got AB, because this arrow is going for AB. So because I'm going in the opposite direction, it's going to be the inverse of it. So it's negative M. This arrow here from A to D, I will be following that same suit. So it's N. And then from D to C, I'll be going in that same direction. So this is okay. Now, when we simplify this, we'll actually have negative M plus 3M plus N, which is 2, which is 2M plus N. And that is the vector BC. All right, 2M plus N. So we're looking at 2M plus N. Next question. L is the midpoint of CD. Find BL. L is the midpoint of CD. Let's look where CD is. CD. L is the midpoint of CD. Now, if L is the midpoint of CD, we want to put on some quick labels here. L is the midpoint of CD. So it means then from D to L, it means then from D to L is 3 over 2M. And from L to C is 3 over 2M. That's what it means, right? So we are able to put on those. And then now they want us to find BL. BL. So let me clean up this diagram here. BL. If we want to find BL, then there are two ways to get there. But I'm going to take the shortest route. I'm going to move from B to C and C to L. Let me do it on the side here. We were asked to find BL. We just got information that L is the midpoint of DC, which means that I just expressed that from D to L is 3 over 2M, which is 1.5. And the same thing go from L to C, a half of the journey. B to L could be from B to C plus C to L. Let's look at what we have. From B to C, we just found it to be 2M plus N. And we're heading in that same direction, so it's fine. We're going to be adding C to L, which is 3 over 2M. But watch this. The direction is very important. So we can't put a plus there. We're going in the opposite direction because originally, as you could see, we have DC. Now we're going from C. So it's a negative. Basically, what we have is, if we should organize the like terms, let's look at this. We're talking about 2M minus 1.5M. I'm left with half M, because 2 minus 1.5 is a half, and then we have the M, we have plus N. And this is the vector BL. There it is, BL. And let me see if we have another question. All right, that is it. All right, thank you guys for watching. Please like, subscribe, and share.